Okay, let's just jump right in. What if I told you that one of the oldest ports in the world is actually becoming one of the most futuristic? I mean, seriously, we're talking about the Port of Hamburg. And in this explainer, we're going to break down how they're using some seriously next level tech to fix a problem that could bring the whole thing crashing down. So you got to understand, the Port of Hamburg is an absolute titan. We're talking about Germany's gateway to the world, right? It's this massive, sprawling complex. It's the lifeblood for so many industries. But here's the twist. Its own success, its own massive scale, has created a huge challenge. A challenge that, honestly, threatens to grind the whole operation to a halt. And just to put that scale into perspective, look at this number, 8.7 million. That's how many standard 20-foot containers, the TEUs you see on ships, that they handle every single year. I mean, that is just a staggering amount of stuff. And okay, how do you move all those containers? Well, you've got more than 10,000 trucks rolling through this port every single day. It's this incredibly complex, nonstop ballet of logistics. The place is enormous. We're talking 80 square kilometers. That's basically the size of a city. It's this massive web of waterways, roads, and get this, over 300 kilometers of railway track. So yeah, managing all that, it's an immense task. And this is where you can really see the problems starting to build. The growth has just been explosive. The first container ship showed up way back in 1968. Fast forward to 1990, and they're handling 1.7 million containers. By 2017, almost 9 million. And the projection for 2025 is, well, it's double that, 18 million. You can just imagine the strain. The physical and, more importantly, the digital infrastructure is just groaning under the weight of it all. And that brings us right to the heart of the matter, the port's connectivity crisis. You can think of the communication networks as the port's nervous system. It connects everything. But the old system, it just can't keep up. It's not built for a modern data-heavy operation like this. Okay, check this out, because this example just nails the problem perfectly. Every year, the port has this huge anniversary festival. Up to 1 million people show up. And what happens? Everyone's on their phones, and the public cell network, the LTE network, it just completely tanks. It gets totally overloaded. Now, imagine you're trying to run something critical, like, I don't know, the traffic light system for all those trucks on that same public network. No way. It's just not reliable enough. So here's the deal. All the usual tech here, public LTE, Wi-Fi, even those long-range networks, they're all sharing the same airwaves. They're public roads. That means you get no guarantees. And for the folks running the port, that's a non-starter. They need something totally different. They need guaranteed reliability, communications that are practically instant, that's what we call low latency, and a network that is rock solid, one that absolutely will not fail when things get crazy. So that's the big question, right? How do you actually build a network that can't fail? A network that's tough enough for the port of the future? Well, the answer, it turns out, is a pretty groundbreaking experiment with 5G. So the Hamburg Port Authority, the HPA, teamed up with Deutsche Telekom and Nokia, and what they did was test a private 5G network. Think of it like they built their own private, multi-lane superhighway just for port data. No public traffic allowed. And the secret sauce that makes all this possible is this incredible technology called network slicing. The highway analogy is perfect. The whole 5G network is the massive highway. Slicing lets you digitally paint lines on that highway to create dedicated private lanes. So you could have, say, a super fast, ultra-reliable express lane just for the traffic lights. And right next to it, you could have a massive 10-lane superhighway for huge amounts of data. And it's all part of the same physical network. It's amazing. So let's look at how they actually used this in the trial. They tested 3 big ideas, each with its own special slice of the network. First, for the smart traffic lights, they needed a slice that was all about being super reliable and super fast, that URLLC slice. It guarantees an instant response, which you absolutely need for traffic. Then, for engineers using things like AR HoloLenses to look at 3D models out in the field, they needed a huge pipe for data. That's the eMBB slice. And finally, to connect thousands and thousands of tiny sensors on barges and bridges, they used a slice designed to handle a massive number of small connections all at once. Pretty clever, right? And the results? Yeah, it was a massive success. The CEO of the Port Authority, Jens Meyer, said it perfectly. He said the test gave them a glimpse of the huge potential of 5G and network slicing. It's exactly what they needed to really break through on their digital goals. And I mean, just look at this chart. The improvement was just dramatic. Latency is just a fancy word for delay, right? The time it takes for a signal to go out and come back. And they just crushed it. By moving the computer processing closer to where the action is happening, that's called edge computing, they got the delay down to under 20 milliseconds. That is practically instantaneous. For anything that needs real-time control, that's a total game changer. But here's the thing. This isn't just a story about a cool new network. That 5G backbone, it's the key. It's the thing that unlocks a much bigger revolution happening at the port. And that revolution is all about automation. You know, automation isn't actually new to Hamburg. They've been doing this for a while. One of their terminals, the CTA, has been using automated vehicles and cranes since way back in 2002. Another huge terminal is also bringing in automated systems. But 5G, that's what's going to provide that super reliable, high-speed connection they need to really kick this automation into the next gear. So where is all this headed? What's the ultimate goal? Well, it's something even more ambitious. It's about building a digital twin. And what that means is creating a complete, living, breathing, real-time virtual copy of the entire port. So how do you do that? Well, first you build a super detailed 3D model. Then you plug it into all the real-time data streams coming from everywhere in the port. So it's not just a static picture, it's a living model. And this is the magic part. You can use it to monitor what's happening right now, but you can also use it to play what if. You can simulate future scenarios, test out new ideas, and spot traffic jams or other problems before they actually happen in the real world. And just when you thought it couldn't get any more futuristic, it does. They're now taking another leap into something called quantum-inspired computing. They're using this wild piece of hardware called a digital annealer. Its only job is to solve problems that are just way too complex for normal computers. And what are they using it for? To figure out the absolute mathematically perfect traffic light pattern for the entire port, changing it constantly in real time. That's a calculation so huge, a regular computer couldn't even touch it. So what's really important to get here is that Hamburg isn't just doing this for themselves. They're not on an island. All of these incredible innovations, they're part of a much, much bigger picture. The vision is to connect smart ports all across the planet. It's called the chainPORT initiative. It's a global partnership that Hamburg and Los Angeles kicked off. And it's all about creating a whole network of these intelligent ports that talk to each other, share data, and share what works. Their whole philosophy is digital first, physical second. Basically, use smart technology to get more out of what you already have before you go spending billions on building new stuff. It's all about making the entire global supply chain smarter and more connected. So when you look at Hamburg, what you're really seeing is a blueprint for the future. A single port creating its own hyper-connected digital world, squeezing every last drop of efficiency out of every truck, every crane, every single ship, all in real time. And that leaves us with one last, really big question to think about. If this is what one smart port can do on its own, just imagine what happens to global trade, to our supply chains, to everything when they all connect.